Hello, Math 8 students. This is Open Up Resources Unit 2, Lesson 5, More Dilations. To get started, we have this diagram, and we are told that all of the triangles in this diagram are dilations of triangle D. The dilations all use the same center P, but different scale factors. So, what is it that triangles A, B, and C all have in common? And what do triangles E, F, and G all have in common? Specifically, how does it relate to scale factor? Here's what I observed. Triangles A, B, and C are all smaller triangles. They're smaller than the original. And if they're smaller than the original, that tells me that the scale factor is less than 1. And here, triangles E, F, and G are all larger triangles. And that tells me that the scale factor was greater than 1. Now I want you to look for other things that you're noticing, kind of like a notice and wonder, but just noticing this time. There are specific characteristics that I hope that you observe. Pause the video to notice a few things and then come back and review the things that I wanted you to notice. One of the things that I hope that you noticed is when I'm looking at corresponding parts of each of these figures, I notice that each of those corresponding parts all line up. For example, this angle and this angle and this angle are all corresponding parts. So when I try and line up the vertices of each one of those, we can see that they all lie very nicely in a line. And for whatever reason, this has been a little bit glitchy. It's not letting me get exactly there, so it's a good thing that it's already drawn. But do observe that each one of those vertices lie in that same line that goes all the way back to the center of dilation P. And we can see that with each one of those vertices, each one of the vertices is collinear, meaning it lies in that same line with point P. I'm going to write that down. Corresponding parts are collinear. That means they lie on the same line with the center of dilation. I do also hope that when we're talking specifically about corresponding parts, I hope that you observe that the corresponding angles are congruent. Although the side lengths may be changing, the corresponding angles are congruent. Let's move on. Things that I need you to remember about dilations. Dilations are a transformation that produce scaled copies. Therefore, it is not a rigid transformation since it produces scaled copies. Angle measures are preserved. That means that they stay the same. Side lengths do not stay the same, however. They are scaled up or scaled down. Dilations produce non-congruent figures. Again, that's why it's not a rigid transformation, because it produces non-congruent figures. But dilations do require two really important pieces of information. They require a center of dilation, and they require a scale factor. And we're going to notice today that they also require one other thing that's so obvious we don't always remember that we need to mention it. To get started, we've got this little task that students did in class where they worked in partners. I'm going to have to be your partner and I'm going to have to be a video, so it's not going to be exactly the same. But here's how it works. You are given this problem card, and I have specific data, specific information that's going to help you answer what this problem is saying to do. So it says polygon AFID is dilated. Draw the image of AFID under this dilation. And you say, well, I don't even have an AFID. I don't have a polygon. I don't have anything to do this with. And that's where I come in. I have all that information. You need to be thinking about what specific information you need. If we were doing this in person, you would ask me questions like, since I have polygon AFID, I need to know where point A is. do you know where point A is? That would be a question that you would ask me, and I would answer that yes, I do know where point A is. And I would tell you that point A, let me switch to a different color, point A has the coordinates 0, 6. Then you would need to take that information and plot that point. A, 0, 6 would be this point. Now you've taken care of A, we've got a few more problems to answer. The next question you might want to ask me then is, where is point F? And I would look at my data and I would see that point F has the coordinates of 6, 0. So I would plot that point, or I would give you that information and you would take that and you would plot that point. We're going to continue on with this. I want you to pretend like you're the one asking the questions, even though I have to ask the questions so that I can also answer them. So please be following along to be able to complete this problem. We now have done F. So the next logical question to ask is, where is point I? And point I has the coordinates 0, 6. So you would take that and you would plot that point. I'm going to be a good mathematician using Math Practice 6 and being precise, and I'm going to go back and I'm going to label these points that I did not label earlier. The next logical question to ask is D. Where is D? And I would tell you that D has the coordinates of -6, 0. So you would plot that point, -6, 0, and being precise, we would also give it the label of D. So it says polygon AFID is dilated. We haven't done the problem yet. All we now have is just where AFID is. I'm going to turn it into a polygon by connecting these points. So A to F, F to I to D, and then we close the polygon up by going back to the beginning, A. It's kind of like a dot to dot, but in a dot to dot, instead of going 1, 2, 3, 4, I'm going in this order, A to F to I to D. Now we're ready to draw the image AFID under this dilation. And you might be saying, what dilation? Again, that's the question you should be asking me. What dilation? The dilation, I would tell you, has a center of dilation of 0, 0. So the center of dilation has coordinates 0, 0. So we would plot that and understand that this is the center of dilation. The next question you should be asking is, what then is the scale factor? And I would answer that the scale factor for this dilation is 1/3. You now have enough information. Let's point out the specific pieces of information that you need. You needed, and this is where the part that I told you was so obvious that we forget that we actually need it, we need to know where the original figure is. We need to know what point we're actually going to be dilating. After we know the original pieces of information, then we can ask what's the center of dilation and what's the scale factor. But knowing the center and the scale factor won't do us any good if we don't know what we're actually talking about. Well, now we do know what we're talking about. We do know the center, we do know the scale factor, so now it's time to dilate this figure. And I can see when I'm looking at A from the center of dilation is 1, 2, 3, 4, 5, 6 away. So 6 with a scale factor of 1/3 tells me that the distance is now going to be 2. So now I'm going to be going in that same direction, but I'm only going to go 2 away, and there is my A prime. Continue on until you have completed this dilation. F has a distance of 6 away, but with that scale factor of 1/3, 6 times 1/3 is also 2, and so instead of going 6 away, I'm only going to be going just 2 away from that center. There's F prime. Continuing on, I hope that you agree I don't need to continue on with these calculations. 6 away, 1/3 of 6 is 2, so it's 2 away. There's my I prime. D is also 6 away, and 1/3 of 6 is just 2, so it's 2 away, and there is D prime. We're not done yet. Yes, we found the new location of those points, but we need to actually dilate the whole polygon. So these vertices help us know what that polygon will look like, and then we draw those line segments, actually turning it back into a polygon. So again, let's recap. What information did we need? The first questions that you needed to ask me were, where are these original points? Once we knew where those original points were, then we could start worrying about the dilation, like what is the center of dilation and what is the scale factor? Let's repeat this process See, here is my data card. This is where I got my information. Let's repeat this process here with problem card 2. Polygon ONPQ is dilated. Draw the image of ONPQ under this dilation. Now, you're saying I'm missing some information. I want you to first think about what information it is that you need. Make a list of all of that information. Pause the video if you need more time to make your list. Now that you have all of the list of all the information, let's look for that information. I'm going to move to a new screen where you are going to see the data card along with the problem card. So here's the problem card, the problem you're supposed to be solving. Here's the data card where all of that information is. You need to now look for that information. Pause the video to complete this problem and then come back to see the answer. Some questions you should have asked, the list of information you should have included would have been, where is O? And O, as we can see, has the coordinates 0, 0. So I'm going to plot that and label it. N, we should have asked the question, where is N? N has the coordinates 2, 2. So I would have plotted that and labeled it. Then we would have asked the question, where is P? P has coordinates of -4, 0. So we would have plotted that point. And Q, where is Q? Q has coordinates of 2, -2. So we would have plotted that point. This is where it gets to be really tricky. Just like I said before, it's like a dot to dot, but it's telling us the specific order that we need to go in. We go from O to N. So starting at O to N. Then following that dot to dot, we go N to P. Continuing on with that dot to dot, P to Q, and finishing up that dot to dot Q back to the beginning. So this is the polygon that we should have created. Please note, if we're not paying attention, we might have come up with a very different looking figure that maybe looks something like this. Okay, so we do need to make sure that we're going in the order of the points that it gave us, O to N to P to Q, and then back to the beginning. Now, let me get rid of those since we no longer want those to be there. And now we have our original figure in place. Now we need to do that actual dilation. The other pieces of information that you should have asked are, where is the center of dilation? And we read over here on the data card and we can see that the center is different. This time it's -4, 0. So -4, 0. That was already on the diagram, so this is going to look a little bit different. This one here is the center. And then we also should have asked, what's the scale factor? And we go over to the data card and we see that the scale factor is 3/2. Also known as, and I'm going to just write it 1.5 to make those calculations easier. 3/2 is equal to 1.5. And now we have all the information that we need. Now it's time to actually do that dilation. Here's some things to observe. This first one is easy, but I would like to point out that from P to N and our new N, wherever it's going to be, are all going to lie on that same line. They're collinear, just like we observed in our warm-up. And P and O, and wherever O prime is going to end up, are all going to lie on that line. And P and Q are all going to lie on that same line. So now that kind of gives us an idea of where we can expect these points to be. Now we just need to complete that. I don't want this diagram to get too messy, so I'm going to not pause the video, but I am going to just lighten these up a little bit so that we can still see what's going on. Makes it a little bit easier to focus on what we need to be focusing on. Let's first take a look at O, and we can see we want to know the distance from P to O, and we can see that it is 4 away. Now 4 away from the center with a scale factor of 1.5, that's going to be 4 times 1.5, and 4 times 1.5, do the calculations if you haven't yet, that's going to be equal to 6. So what was 4 away has been dilated to now be a distance of 6 away. 1, 2, 3, 4, 5, 6. So here is O prime. Let's repeat that process. Challenge now is N and Q. We can't actually measure and see how far away they are. We've got to use the information on the grid. such as to go from P to N to measure that distance, I'm going up 2 and to the right 6. So up 2 and to the right 6. So going up 2, that's going to be dilated and multiplied by 1.5. 2 times 1.5 is going to equal 3. So when we were going up 2, now we're going to be going up 1, 2, 3. And before we were going right 6, but that is also dilated. 6 times 1.5 is equal to 9. So I was going up or to the right 6, now I'm going to be going over to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how about that? It ended up right on that line that I suspected it would. There is N prime. Let's do the next one. Q, measuring that distance by counting how far down and across we're going. Looks like I went down 2, and I'm going to be going to the right 1, 2, 3, 4, 5, 6. Changing that by a scale factor of 1.5, so 2 times 1.5, and then 6 times 1.5. And 2 times 1.5, we already did that calculation up here. That's equal to 3. And 6 times 1.5, we did that calculation up here as well. And that's 9. So instead of going down just 2, I'm going to be going down 3. And instead of going right 6, I need to go down right 7, 8, 9. And there's Q prime landing just like I suspected it would on that line. What about P? Think about this. If P is the center of dilation and I try and dilate it, it just stays the center. So P and P prime end up being the same. And we now have all of the points we need to draw our new figure. P to N, N to O, O to Q, and Q to P. And there is our new dilated figure. I hope you were successful and yours looks just like mine. If not, make sure you took notes because we are moving on. Are you ready for more? Triangle EFG was created by dilating triangle ABC using scale factor 2 and center of dilation D. Triangle HIJ was created using triangle ABC as the original, but using scale factor 1/2 and still using center D. So with that in mind and with this beautiful diagram, I want you to make a prediction. What is it going to look like if I try to do a dilation of triangle ABC with scale factor of 0? Pause the video long enough to make a really good prediction about this. Now that you have your prediction, let's take a look and see. What I'm noticing when I'm doing this dilation, the figure is getting bigger. Now, of course, I'm not dilating with that center. I'm going to have to move it so it actually looks like that. But when I'm increasing that number, the triangle is getting bigger. And when I'm shrinking it down using a smaller and smaller and smaller scale factor, you can see what's going to be happening. It's getting smaller. If I keep going, it's going to get even smaller. Look at what's happening. Think about that. A scale factor of 0 means that all three of these points are getting closer and closer and closer and closer together until they're all the same point. So you can think of it a couple different ways. You can say all points, all 3 points of the triangle ABC end up being point D. Another way to think about it then, does that even exist? You maybe made that prediction that maybe it doesn't exist, and that's an okay prediction to make because it reminds us that it is going to be getting smaller and smaller and smaller and smaller until all points all line up there. With that in mind then, what would the image of the triangle look like under dilation with scale factor of -1? We got smaller and smaller and smaller, but now that we're in the negatives, what happens? This diagram gives us a really good clue. When I look at this, I can see that from D to B, it's that distance. That would be a scale factor of 1. If I just multiply everything by 1, it's going to stay exactly the same distance that it is, and so it will be in place there. So what if I multiplied it by a -1? So these numbers are getting smaller and smaller and smaller and smaller and smaller until I get even smaller in the negatives. And -1 would be that same distance away, but on the other side. So here is where point B prime would be. Let's repeat that process. What about A? A goes from here to here. And just like all of these other points, H, A, and E, they're all collinear, they all lie on that same line. I would guess that when I do a different scale factor, it still is going to lie on that same line. But now, here's that same line, but going all the way back smaller and smaller till we're on the negative side. Here is where A prime ends up. And continuing on, D to C here. Going to be collinear because J, C, and G are all corresponding parts and they're all collinear. So this one would also be collinear coming all the way back here. And here is our C prime. Interesting to note, A was on the top, but now A prime is on the bottom when I multiply it by a scale factor of -1. C was on the bottom, but now C prime is on the top when I multiply by that scale factor of -1. So when I actually draw this triangle out, hopefully that makes it pretty easy to observe what happened. Describe what happens to a shape if it is dilated with a negative scale factor. And what's happening is it ends up being a reflection. And now we have made it to our Lesson 5 summary. One important use of coordinates is to communicate geometric information precisely. We needed to know exactly where each of those points were, and we can communicate that using our coordinates. So let's consider quadrilateral ABCD in the coordinate plane. Performing a dilation of ABCD requires 3 vital pieces of information. The first are the coordinates of A, B, C, and D. This is one of those things that it just seems so obvious that we forget that we actually need it. We need to know the original information. We also need to know the coordinates of the center of dilation. And we need to know the scale factor of the dilation. Those are those 3 vital pieces of information. With this information, we can dilate the vertices A, B, C, and D, and then draw the corresponding segments to find the dilation A, B, C, D. Key thing here, because I know a lot of students in class forgot this, you do have to draw those corresponding segments. Finding specific points is great, but we need to make sure we complete it by drawing all of those missing segments. Without coordinates, describing the location of the new points would likely require just sharing a picture of the polygon in the center of dilation. If we can't describe where those points are, we were going to have to show it by showing that picture. Here is your Lesson 5 cooldown. And it says the smaller triangle is dilated to create the larger triangle. The center of dilation is plotted, but is not labeled. We need to describe this dilation. Make sure that we include all the information that someone needs. Keeping in mind, we need to know the original pieces of information, where the original figure is, the center of dilation, specifically the coordinates of that center, and the scale factor. Pause the video to write down all of that information that you need and then check the answer. Here's some of the original pieces of information. If I label this A, B, and C, then I would say point A has coordinates 2, 0, B has coordinates 5, 1, and C has coordinates 4, -2. So we would need the original information. We would need to know the coordinates of the center of dilation, and the center of dilation is right here. It's been marked for us. The coordinates for the center are 3, 0. And finally, we would need to know the scale factor. The scale factor, here's the easiest way to check. The distance from the center to original A has a distance of 1. But the distance from the center of dilation to our new point A prime has a distance of 3. So how does a 1 change to a 3? It's because we're multiplying by 3. So the scale factor here would be 3. We can observe that in a few other places as well. This point goes 2 down and 1 across. And the distance to the dilated is 1, 2, 3, 4, 5, 6 down. So again, how does that 2 change to being going down 6. It's because we're multiplying by 3. And what was going over 1, now we're going over 1, 2, 3. And again, how does that 1 change to a 3? Because we're multiplying by 3, making our scale factor 3. Here's your practice problems. I do expect them to be completed. Don't forget to go back and complete your cool down in Canvas for you online learners. That's it for today. Thanks for watching. We'll see you next time.